Hi Year 13. This is me going through a paper that's designed to prepare you for the topics that are coming up next week. So, this first question, it says, given that y is 1/27th of x cubed, express each of these. So the first one, we're going to do 1/27th of x cubed to the power of a third. So that would mean that for the x, we do a 3 times a third, which gives you x. And for the 27, 1/27, we need to do the cube root of 27. So that would mean that we have 1/3 of x. Okay, next one. 3y to the minus 1 would be 3 lots of 1/27 x cubed to the minus 1. So if we do to the minus 1, for the power, like always, we times them, but we also need to do the reciprocal of 1/27th, which is 27, because we essentially flip the fraction upside down. So 3 lots of 27x to the minus 3 is 81x to the minus 3. Now, normally, you could have left this as that, or 81/x cubed, but it says in this that we need it to be in kx to the n. So we want it as x to the minus 3, not over x cubed. And the last one, it says 27y, and y is 1/27x cubed, all square rooted. So that is a single x cubed, all square rooted. And the square root is a power of a half. So we've got x cubed to the half, which is x to the 3/2. Okay, question 2. It says, find the coordinates of point A, which is a minimum. So as soon as we're doing anything to do with minimums, we're going to want to differentiate and find out when dy by dx equals 0. So if we start by writing out the function as a standard, in a standard way, such as 8x to the minus 1 plus 0.5x minus 5. So in this one, if we're finding the minimum point, we need to work out f dashed of x, which is, we multiply by the minus 1 to get minus 8x, and lower the power to get to the negative 2. And then 0.5x differentiates to make just 0.5. So finding out when this is equal to 0, we would get that 8x to the minus 2 equals 0.5, or x to the minus 2 equals 1/16. And remembering that that's x to the minus 2 means 1/x squared is 1/16. We can, because we only have one fraction on each side, we can essentially flip it and say x squared is equal to 16, which means that x is plus or minus 4. Now, in this one, technically you've got both answers, but there's a restriction in the domain of the question, because it says in the question that it's between 0 and 12. So actually, x is 4. Once we know that, we can find out the y coordinate by just putting 4 into this. So we get 8/4 plus a half of 4 minus 5. And when I say into this, I meant into the function, because the function is what defines the y coordinate. So we would have 2, add 2, take 5, which is minus 1. So our coordinate is 4, -1. So then state the roots of the equation if 2f of x equals 0. Well, 2f of x would be just a stretch that way, of a scale factor of 2 about the x-axis. So you start off with the x-axis and then everything gets stretched up or down. So actually the roots for 2f of x would be exactly the same. They would be 2 and 8 still, because all the place on the x-coordinate would not change, sorry. The coordinates of the turning point of the curve f of x plus 2, that shifts everything up by 2. So if we were at 4 minus 1 and we move that up 2, we would be at 4 positive 1. And the roots of the equation f of 4x, what that does is it compresses everything in towards the y-axis, because you actually divide all the x-coordinates by 4 in that situation. So everything, when it's inside the function, inside f of x, it does the opposite. So f of 4x divides by 4. So that means that instead of the coordinates 2 and 8, we would have a half and 2. So that's our second question done. Third question, binomial expansion. So it says the first 3 terms of that are these 3. Find A and find P. Well, if it's telling us that the first 3 terms are these, then let's find the first 3 terms of this binomial expansion and see if we agree, or see if there's any comparisons we can do. So there's a couple of versions of the binomial expansion you've seen now. I'm going to, since we're talking year 12 content, just stick to the a plus b to the n is a to the n plus n choose 1 a to the n minus 1b plus n choose 2 a to the n minus 2b squared. I'm sticking to that. You could, if you wanted, do this with 1 plus x to the n is 1 plus nx plus n minus 1 x squared over 2 factorial as well. And I would personally say that the second one is probably easier, but since that's not technically included in year 12 content, I'll leave that one for now and we'll just cover this one in pink. So I'm going to start off by expanding 1 plus ax to the 20, and that will give us 1 to the 20 plus 20, choose 1, 1 to the 19 times ax, and then 20, choose 2, 1 to the 18 times ax squared. So that is 1 plus 20 times 1 times ax, so 20ax, and 20 choose 2 in my calculator gives me 190, so that's 190 times 1 times a squared x squared. You have to make sure that you expand the power to both the a and to the x. Okay, so going back to the question that you can just about see at the top, they are saying this is apparently the same as 1 plus 4x plus px squared. So that means that 20a is apparently the same as 4. And it also means that 190a squared is the same as p. So if we look at the bit in blue first, that tells us that 20a equals 4, a is 1/5. And then p is 190a squared, which now that we know that that's a fifth, it's a fifth squared, which is 25, 1 over 25. So it's 190 over 25, which does cancel down a little bit to, what would that be? So that would be 7 and 3/5, I believe. Or you could call it 38 over 50. Over 5, sorry, not 50. So that is the second one sorted. Third question, actually. Okay, pretty standard circle question. They've given us a expanded version of the formula, and we're going to have to complete the square on the x terms and on the y terms to try and find out what the coordinate, the centre is, and what the radius is. So, get the x's next to each other, get the y's next to each other, and if we take this section here, that would turn into x minus 4 squared, take away 16 when we factorise it. And this would turn into y plus 2 squared, take away 4 if we factorise it. And we still have the minus 12 on the end. So altogether, we have x plus 4 squared, y plus 2 squared, and that's minus 32, which if we put it onto the other side would mean that it equals 32. So our centre of our circle is these, to do with these two values, but you swap the signs. So it's 4 and minus 2. Our radius squared is equal to this value, 32. So when we root it, you'd get root 32. But if it doesn't say it here, but if it said to simplify it, that would be 4 root 2. The circle cuts the y-axis at A and B. Find A and B. So the main thing that you need to do at the start of this is that the y-axis, did I say the y-axis? Yeah, the y-axis, oops. The y-axis is when the x coordinate is equal to 0. So if we take either version of this, it might be easiest if you take the original version, but it doesn't matter, and we put x equals 0 in, we'd end up with 0 squared minus 8 lots of 0 plus y squared plus 4y minus 12 is 0. So we're just left with the y terms. And if we solve this, we will find out where it touches the y-axis. So since that factorises to y plus 6, y minus 2, that gives us minus 6 and positive 2 as the two places it touches the axis. Okay, so if it says show that x plus 2 is a factor, we're talking factor theorem. So the factor theorem is that if x minus a is a factor, then f of a should equal 0. So for this one, I'm going to put minus 2 into my function. And then when you calculate it, that would turn out to be negative 16. That would be negative 20. Add 56, take 10, which if you work it out is 0. And because it's 0, therefore x plus 2 is a factor. So now that we've worked out that we've confirmed that it is a factor, it says fully factorise, so that would be a case of doing some long division. Now, whichever you prefer out of the traditional way or the grid method is up to you, but you do need to understand how the grid method works as it's part of the syllabus. So I'm going to, not grid method, the traditional way works. So I'm going to go through that. So how many x is going to 2x cubed? It would go in 2x squared times. If we then multiply x plus 2 by 2x squared, we get 2x cubed plus 4x squared, which subtracted from each other would get you negative 9x squared. And bring that down. So x goes into minus 9x squared minus 9x times. Multiply through again and subtract, and we get negative 5x. How many times does x go into minus 5x? Minus 5 times. Multiply it through and subtract, and we get 0. So that means at this point we know that this 2x cubed minus 5x squared minus 23x minus 10 factorises to make this, but it does say fully factorise, so you need to then factorise the 2x squared minus 9x minus 5, however you prefer factorising quadratics, to get 2x plus 1 and x minus 5. So, hence solve that thing. So, basically that is exactly the same thing that we had before. Because, well, not exactly, but very similar. So if I made this equal to 0, and I moved the minus 10 to the other side, we would end up with 2x cubed minus 5x squared minus 23x equals positive 10, which is basically what we have there. So if our solutions to the question before, was this part D, would be minus 2, minus a half, and 5, from these factors, then we can say, okay, we need to solve when is 3 to the 3t equal to minus 2, 3 to the 3t equal to minus a half, and 3 to the 3t equal to 5. And not that many times, because a number to a power cannot be negative, so this and this do not have solutions, but we do have a solution for 3 to the 3t equals 5. So if we do log to the base 3 of each side, we'd get that. So 1/3 of that would be the solution. Now, you could have done natural log of each side and also got a similar, well, get the exact same answer as well. But I just chose to do it with log to the base 3 because I think it makes it a bit more straightforward. Type that in my calculator and we get, I believe, 0.48823 decimal places. And I think it said 3 dp. Right, question 11. That is f dashed of x. We want to find f of x. So we need to take our function, which if I write it in a more standardized form for integration would be this. And we need to integrate it, because that is the opposite of differentiation and we have the differential. So you raise the power by 1 and divide by the new power. In the case of 2, that becomes 2x. And you always have to remember your plus c. You will lose marks if you don't remember your plus c. And in this one, you'd lose a few marks because we also need to find out what that c is. So that would get you 2x to the 3 over 2 minus 18x to the half plus 2x plus c. And that is what f of x is. They have told us, though, that 914 works with this. So if we put 14 in here, that would be what you get if you work out all of this. So, meant to be a C there. So you've got the square root of 9 cubed, which is 27, times 2 is 54. That's 18 times by 3, which is negative 54, plus 18 plus C. So altogether, C is negative 4. So we have our function, same as before, but now I know the C is negative 4. Form an equation of the normal to C at point P, giving your answer in the form ax plus by plus c equals 0. So whatever our curve is, and my guess here is probably going to be completely wrong, the normal is different to the tangent. It doesn't go in the same direction. It goes at 90 degrees. So what I need to do is I need to put in my coordinate into this, because this is the gradient function, and find out what the gradient at that point is. Once I have, though, I don't want that gradient because that would be the tangent. I want to find out what the negative reciprocal is to be able to find out the normal. So f dashed of, the coordinate 9 from here is 3 lots of 9 to the half minus 9 lots of 9 to the minus a half plus 2. So that's 9. Take away 3, add 2, which is 8. So the gradient of the normal is the negative reciprocal of that, which would be negative 1/8. So the normal gradient is negative 1/8. Okay, so now, if you remember, we're finding the normal that goes through the point 14. So if we do y minus y1 equals mx minus x1, we can get our equation. So y take away 14 is negative 1/8 of x take 9. And if we expand it, we get that. Always remember what form you're looking for. We're wanting it in ax plus by plus c, where they're all integers. So if I times everything by 8, 8y minus, I think that's 112, just check. Yep, 112 is minus x minus 9. So x at 8y minus 103 equals 0. Okay, question, well, I say 7, but whatever question we're on at this point. So, it's a radians question and it's a trig identity. We are trying to solve that, giving your answers to radians, in radians to 2 decimal places. So the first thing we need to do is convert it so we have the same kind of trig function to deal with. And it doesn't matter whether you turn it into cosines, the cos squareds, or into sine squareds. So just picking one, I'm going to use the fact that sine squared plus cos squared equals 1 to replace this with 1 minus sine squared. And then expand so that altogether we have 4 equals 7 sine squared x. And that means 4/7 is sine squared x. Sine is the square root of that, which if we square root 4/7, we get 2 root 7/7. But you don't just get the positive root, you get the negative root, so we're going to have to solve both of these to get all of our answers. So if we sine minus 1, 2 root 7/7. Right, so sine minus 1. Oh, first thing, make sure, unlike me, you're in radians before you carry on, because the question's in radians. So sine minus 1 of that answer would get us 0.857. And you also need to do the other solution, which if you remember in sine is 180 minus or pi minus. So if we do pi minus that answer, your other answer is 2.285. For the negative solutions, we get sine minus 1 of negative, that gets us minus 0.857. And if you do 180 minus, or pi minus, sorry, we get 3.999. Now, because I've got one of my solutions that's negative, I have a sneaking suspicion that we don't have all of the solutions from 0 to 2 pi. So if you remember, to get more solutions, you add 360 degrees and take away 360 degrees from your initial solutions. So if we do that with negative 0.857 and we add 2 pi, we do get something small that's still within the range, which is 5.426. So this one was not in the range and that one is. So just to write out our answers to 2 decimal places as they've requested, we would have 0.86, we'd have 2.29, 4.00 and 5.43 as our 4 answers. I meant to take that one out because we've already got that one. So I'll delete that. Hopefully I'll take it out of yours before I send it to you. Okay, our last one is finding an area enclosed by a curve and a line. So first thing it's asking us to do though is find out what the coordinates of A and B are. So we want to find out, when does this equation meet this equation? And to do that algebraically, we would say, okay, when does x squared minus 2x minus 15 equal 2x minus 3? So to solve this, get everything on the same side and set it equal to 0. So it happens when x squared minus 4x minus 12 is equal to 0. Or when x is 6 and when x is negative 2. So we want coordinates of A, so we also need to find out what the y coordinate is. We might as well use the easier formula to calculate and say, okay, when x is 6, y is 2 lots of 6, take 3. 12 take 3 is 9. So 6, 9. And when it's minus 2, you've got 2 lots of minus 2, take 3, which is minus 4, take 3, which is minus 7. And looking at the diagram, the negative 1 is A, the positive 1 is B, based on where they both are. Okay. So now we want to use integration to find the exact area. So in that diagram, you've essentially got two things. You have a triangle like that you can work out just using a half base times height, if we can work out what this height is and what this base is. But there is a small slither here that we need to subtract. To do that, we do integration of the area under the curve between this point here, which we've worked out to be 6, I believe, I'll check that in a second, and this coordinate B. Was it? Sorry, it was B that's at 6. We need to find out what that one is. So, first thing I'm going to do, just to make things easier, is I'm going to work out what these two coordinates are. So, if I want to find out when is x squared minus 2x minus 15 equal to 0, I would factorise and get that it's at 5 and negative 3, which looks like it makes sense, but for the sake of this diagram here, that would be 5. If I want to find out where this line meets 0, do the same thing again. So we set y equal to 0. 0 is 2x minus 3, so 2x equals 3, x is 1.5, or 3 over 2. So we know this point here, B, which is at the coordinate 6, 9. We can work out the area of the triangle that goes from 3.5 to 6, and from 0 up to 9, by doing a half of the base, which is 4.5 wide, times the height, which is 9 wide. So half times 4.5 times 9, which gets us 20.25. So that's this area all the way from here to here and across. So then what we need to do is take away that tiny slither. So I'll do that in a different colour. We want to take away this section here between 5 and 6 that's underneath the curve. So we need to integrate between 5 and 6, the curve, which is x squared minus 2x minus 15. Now you can do that on your calculator, but I'm going to talk through the proper steps so that you understand them. Let's make that small to give myself a bit more space. So raise the power by 1 and divide by the new power for all of these. And when you're doing a definite integral, that's one where it's between two numbers. That's the one time you don't actually have to put a plus c in. If you do put a plus c in, it won't stop anything, but there's no need to. So we need to calculate 6 cubed over 3 minus 3 squared minus 15 lots of 3. Not 3, sorry. These should all be 6's. Take away 5 cubed over 3, take 5 squared minus 15 lots of 5. And if we type that in a calculator, which I'll just do now, we get 25 over 3. 25 minus 75. That's an area of 13 thirds. So our total area would be the area of the triangle, which was 20.25, take away the area of that slither, which is 13 thirds. And altogether that gives us an answer of 191 over 12. Okay, so that is all of the questions. So if you have any questions, just feel free to email me about that, or if you spot any mistakes. And hopefully now that this video is on YouTube this time, the quality is significantly higher than it was on Teams.